Hi, I'm Keith Smith, COO of Intelliam. In this video, we're going to take a look at the machine reliability dashboard within the Intelliam platform. The layout of our live status dashboard is designed to quickly highlight the top components that are trending into an unhealthy state, either through error, wear, or fatigue. These components are highlighted in the tiles at the top and changes the component's health changes automatically, keeping engineers on the shop floor or maintenance workshops up to date with asset health. We've found that this helps support the on-site engineers with their upskilling and engagement with a predictive maintenance strategy. Each component can be selected either from the top tiles or from the list on the left, so that the detailed raw data can be displayed on the right-hand side. These trends are shown over a time range, which details shown as you hover over the graph. If you're part of a multi-site group, then the site can be selected from the drop-down here, so you can easily switch between sites. The time range to display the data can easily be changed by selecting either predetermined range or you can select your own. The component can be filtered and sorted here, which can be very helpful if you want to compare assets of a similar type. The first thing to understand with the health score is that the parameters are chosen based on the failure modes of the components to ensure mitigation. And we're not restricted to a small number of parameters like vibration or temperature, or any specific sensor types. We continue to see bad practice in industry where vibration sensors are being used on slow speed applications that are not capable of predicting relevant failures. By example, we've proved that vibration was not a good indicator of component health on a slow speed slew ring. You can see that there is very little increase in vibration trend. However, you can see that the stress wave trend predicted the reduction in the component health. In this case, Intelliam generated a work order that prescribed the actions to be taken, which saved the customer 4 days in machine downtime. Intelliam selects the right reliability sensors and use parameters direct from your control equipment to specifically monitor the relevant failure modes of the components being monitored. For example, induction motors, we would use vibration and temperature, servo motors, amps, torque and temperature. For gearboxes, oil condition and stress wave, and PLCs, we could monitor scan times. We then take contextualization data like speed, pressure, product, flow, lubrication timing, in order to overlay on top of the reliability data to allow for dynamic alarming. This means the alarms are generated specifically to that component and its running context, just like an individual's fingerprint. This improves accuracy and prevents false positives. In this example, we can see the motor speed overlaid on top of the reliability data taken straight from the inverter. We not only monitor the health of critical components, but also key auxiliary systems. For example, on this page, we're monitoring an SKF lubrication pump, critical to the health of the components we're monitoring. We monitor the grease level, system pressure, temperature, and the status of the system. This means that we can create work orders on the auxiliary systems, so optimization is achieved to ensure longevity, and actions can be completed before it affects the critical machine components. By using any sensor, any PLC or other auxiliary data, there's no limitations on the type of components that we can monitor, whether it be electrical, mechanical or process error. Once Intelliam has predicted component health degradation, it raises an automatic work order that can be built within your workflow features and in a timely manner to ensure proactive response. This is an example of a work order. On the left-hand side, it tells the engineers which components and machines the work order is for, the reason for the work order, and the prescription of what should be done. In the centre, there is the evidence of the data that we've used to make this prediction, and on the right is a priority to support the engineers in planning the work. By carrying out this work order, our customer is ensuring they are preventing any equipment downtime and increasing the line performance. Thanks for watching this video. If you want to learn more about our platform and how it can help your manufacturing processes, please do get in touch.